You know that feeling, right? You're writing code and then something breaks, and you have absolutely no idea why. It can be so frustrating and, honestly, a little isolating. But what if we looked at it in a totally new way? What if we saw debugging not as a chore, but as this really creative and powerful skill? Let's explore that idea together.
Wow, this quote from Ellen Allman, it just perfectly captures that feeling, doesn't it? That trance-like state where you're so deep in the problem that the rest of the world just fades away. It feels like it's just you against this stubborn demon. But you're definitely not alone in feeling this way, and more importantly, you are not powerless against it.
Okay, so let's get to the main idea here. Debugging isn't just about fixing your mistakes. It's actually a really structured way of solving problems. And once you get the hang of it, it can be incredibly satisfying. It's all about learning on a much deeper level. So, yeah, on the surface, debugging is just, finding and fixing stuff. But every single bug is an opportunity, really. It's your program trying to tell you something you don't quite understand yet about the system you're building. Fixing the error is the goal, of course, but the real win, it's the deeper understanding you get from it. This really puts it all in perspective, doesn't it? This isn't some random chaotic thing we do. It's a discipline with this long, incredible history. When you're debugging, you're not just a coder. You're a scientist. You're a detective, applying a method that people have been perfecting for centuries. So let's dive into a few of those mindsets. All right, first up, let's put on our detective hat. Think about it. You've got a mystery on your hands, right? The weird behavior, the error message, those are your clues. And your job is to systematically figure out what happened. And this right here, this is the detective's #1 tool. You don't just guess randomly. You come up with a cause hypothesis, basically an educated guess about what's wrong. And then you design a little experiment to see if you're right. It's this cycle, see? Hypothesize, test, hypothesize, test. And each time, you're getting just a little bit closer to the truth. A super simple real-world example makes this so clear. Okay, so a lamp in your house isn't working. That's the symptom. Your first hypothesis? The light bulb is probably burnt out. So what do? You test it by plugging the lamp into a socket you know works. This whole process is called binary partitioning. With each test, you're cutting the problem in half, narrowing down where the fault could possibly be. This is exactly what you do with code. And let's just pause here for a second, because this is so, so important. There's often this huge pressure to fix things right away. But honestly, the most powerful tool you have for debugging is your own mind. Rushing just leads to more mistakes. It is always, always okay to just step back, take a breath, and think. So, if the detective looks forward with hypotheses, our next mindset looks backward. This time, we're going to be a historian, tracing the story from the crime scene, step by step, back to the beginning. Backtracking is probably one of the first things you think to do, right? You start right where the error pops up, the symptom, and you carefully trace the code backward. You keep asking, okay, what was happening right before this? And before that? And before that? You're literally walking the path back to find out where things first went wrong. But, the key is knowing when to use this technique. It works great for smaller programs or when you have a really clear idea of where the problem is showing up. But man, once your code gets really complex, the number of paths you could trace backward can just explode. It can get way harder to manage. And here's another thing to remember. Even if you follow a path and it's a dead end, you didn't fail. You actually learned something super valuable. You learned where the problem isn't. Every single step, even the ones that feel like they go nowhere, adds to your understanding. All right, our third and final mindset kind of combines the first two. It's about thinking like a scientist. You're not just observing the bug in the wild, you're trying to capture it so you can study it in a lab, so to speak. This right here is huge. A bug that just pops up randomly, that's a nightmare to solve. So your first goal is to create a controlled experiment. You want to find the smallest, simplest thing you can do that makes the bug show up every single time. Once you can make it fail on command, you control it. And once you control it, you can fix it. Okay, so we've talked about these different mindsets, these ways to think about the problem. But now, let's talk about one of the most practical and honestly most human strategies there is. So what do you think? Is it some fancy piece of software? A special command you can type? Turns out the answer is way, way simpler than that. Oh man, this is Ed. And I think we've all been Ed at some point, right? Just staring at the same screen for hours, feeling totally and completely stuck, and just digging ourselves deeper into a hole of frustration. And then his teammate, Shakira, chimes in. And I want you to notice what she says. She doesn't suggest some technical fix. She brings up a team agreement, a rule they made specifically to stop this exact kind of thing from happening. And boom, there it is. After Ed struggled for 5 hours, Shakira sees the problem in like 30 seconds. And it's not because she's a genius, it's because she has fresh eyes. She isn't trapped by all the assumptions and the blind spots that Ed built up over hours of work. So, if there's one really practical rule to take away from all of this, it's this: the 1 hour rule. Give yourself 1 solid hour to try and solve a bug on your own. But if you're still stuck after that hour, your next step isn't to just keep banging your head against the wall. It's to get help. Ask a friend, a classmate, a teammate. A lot of the time, just explaining the problem to someone else is enough to make the solution click in your own head. Okay, so let's tie all this together, because debugging is so psychological, right? The way we frame it in our heads makes all the difference in the world between it being a source of stress or a source of real growth. And this, right here, is probably the most important shift you can make. A bug doesn't mean you're a bad programmer. It just means there's a puzzle sitting in front of you waiting to be solved. And every single puzzle you solve makes you a more insightful, more capable, and more resilient problem solver. Each one is like a little workout for your brain. So the next time you run into one of those stubborn demons, just take a breath. Remember that you've got this whole toolkit of mindsets you can use: the detective, the historian, the scientist. And remember that sometimes the most powerful tool you have is just turning to the person next to you and asking for help. So, what puzzle will you solve next?